today's class of industrial robotics, we'll be discussing in detail regarding the behavior-based sensor control in a robot. As of now, the technology has been considered. We are facing Android type of robots. The best example related to the Android in a sense, our digital mobile phones or IoT-based working systems of a robot. So, what is the major source existing for the sensor-driven robot? So, we already see in the automation training of the robots. First one is a fixed automation. Secondly, flexible or programmable automation. Third one is a flexible automation. In the case of this fixed automation, the numerical control type of machineries will be existing, and concerned feedback will be raised related to the NC machineries. And in the programmable set of cases, CNC plays a major role. It is computer numerical control technology, editing of the programs, processing the entire programming, and based on the programming, the work is carried on in the computer aided machineries. And third one is an advanced technology. And presently, it is existing very much less in count, that is PLC based operations, programmable logical controller based operations, and PID controllers also, proportional, integral, derivative controllers based on working to get the accurate results when compared with respect to the programmable basis of work as the previous technology is existing. And flexible manufacturing systems. So here, consider the term the flexible. First one is a fixed automation, and here the die system will be existing depending upon the die that we have been framed or given as an input to the system. The work scenario will be progressed. Secondly, programmable basis. The computer guidance will be taken, and the program will be developed. The program will be dumped in the microprocessor. That microprocessor will be placed in the microcontroller, and controller will take care of the processing the instructions related to the programs, and feedback will be given again back by these sensors based on the working to the controller. Third one, it is flexible. So flexible in the sense here, without any contact oriented directly by either the external source, either of the external sources. One, it is physically operating the machineries will be getting altered. Secondary, a programmable basis of working. That's nothing but one IT developer will be existing for developing the program, giving the input instructions to the system, and based on that, the work is getting progressed. And in advance to it, without writing the program, the detection of the signals, that's some voice signals, depending on the trans-receiving capability of the sensors. So here the transit user or trans receivers plays a major role in need to transform the signals from one form to the other form. Next, converting the voice-based signals to the theoretical based and activating its work. And even depending upon the radioactivity or remote based working of the robots, as a radioactive mode of work, which can be altered with the advanced technology, that is a virtual mode of connectivity. So, what's the technique behind the virtually guided robots? So, by using the antenna, the frequency of the IR sensors, the signals from here in the form of a voice commands or else the programmable based commands. Basically, the voice commands will be guided by, by the technician, and at the other end, the robot will be exercising the simultaneous actions depending upon the instructions given by the tutor. The range here plays a major role. So, how far the range may be? So it may be 2 kilometers, 3 kilometers, or 4 kilometers that have the primitive role. That is primitive role. Okay, before moving on to, we need to study the, we are having some key points to understand a detailed structure regarding the virtual mode of robots control. Initially having the sensor driven robot control. So it is existing to achieve the accurate task, nothing but the intelligent environment creation that has to be get reacted dynamically with respect to the surrounding changes. And the robots needs some of the precise sensors, what we will call the prescribed sensors, indeed to get the accurate results based upon the given input commands in the form of old representations or to, by detecting its in and around environmental conditions, trans-receiving of the data from the far place to the present place. Most of the robots use a set of different sensors is served for serving different kinds of purposes. See, for rotation elements and increasing of its intensity, one application, orientation of the fans, switching on of the refrigerators or air conditioners, etc. will be having a different type of applications in the case of domestic oriented. Next, need to transfer the material by the conveyor belt system from one place to another place. It's a second source in our manufacturing areas. Shaping of the input material from the raw material stage to enter into the work part position for prescribed operational process. It's all of the mechanical related process acquisition kinds of the sensors indeed to identify and generating the accurate results based upon the operations that are performed mechanically by different mechanical equipments and its function. Here we are having the basic control of the robot, which will grasp the signals by the individual sensors from different parts of the circumferential area or surrounding that has been captured by its capacity of range or frequency of radiation and giving the signals back to the controller. And even it is exercising different robots or working at different places by giving the commands or executing the commands from only the control space. So there are two different types of sensors we have been discussed in this space class. That is an internal type of sensors and external type of sensors. Internal sensors, so encoders plays a major role and the opaque nature that has been projected from the source of the light. If there is an lighter gaps in between upon its rotation, the light rays used to pass in the empty pores that are existing while its rotation, and as per the coding formation will be generating the output waveform. The limit switch here clearly specifies that the joint has been reached to the limit, automatically it will be signal identifying with respect to its signal. See, here it is a notch, here it is available, and nowhere else at the outer diameter the notch is being existing, and hence this is the pole that is existing that allows the light rays to pass from one side to another side. And after completing its revolution, nowhere else the light rays are being visible to pass. So again, when upon rotation, when this hole has been achieved again to its position, then only the light rays will be allowed to pass through this particular hole. And hence it will be counted as one revolution. So in such a way, these type of sensors encoders used to find out the rotations or identify the speed and controlling of the speed as per the input conditions given. So measuring of the speed. So what the type of the device will be utilized to measure the speed? Tachometers. So tachometers are of two types. Even we have been discussed in the space class also. Contact mode and non-contact mode. Contact mode, it need to be get first with respect to the rotating element, shaft, and hence in the analog display it will be identifying the rotations. And the digital display, the IR rays will be getting passed in the rotating shaft of the motor, and based upon the trans receiving capability, it will be digitally indicating the RPM on the display screen. So here, as per the internal sensor, the counter for the counting basis is encoders plays a major role in the robots. Next one, the proximity sensors. Proximity sensors. These are used to measure the distance or location of the objects within the environment. So this plays a primitive role in the case of the advanced technology aspects. So let us see the examples related to it. The proximity sensors. Infrared sensors, which determines the distance to an object. Upon imposing the amount of infrared lights on the objects, and the reflections will be getting back to the robot. And even the ultrasonic sensors, which receives the sound waves signals again back towards the returns back from striking the ground as stations by passing through the medium and getting reflected back to the original position again. The material, the inspecting material will be specified in between the stack and the source generation point. And laser range, and how far the laser is being exists. This is the conditions in verify here once. The sound waves that will be passing, and when the obstacle has been achieved, it will be getting cut off over their frequency, and again will be coming back as a feedback to the source point, which is being activating as a controller also. That is reflecting it again back to the robot by measuring the laser hits upon hitting the object. These are the written as the pictorial representation. Coming to the visualization or vision concepts. Naturally, upon vision technology, visual basis of work, we used to confine the measurements, geometrical measurements of the objects, and what is the situation that is being taken place, and what kind of situation and in what way the dimensions are existing is either in the length side, breadth side, depth calculations upon visual examination. But if the particle is very much in minute quantity, minute range, which cannot be visualized with respect to our naked eye, then these sensors plays a major important role indeed to find the entire geometrical aspects of the object that can be identified even in the nano scaled range. So means micro range, macro range can be identified upon our human eye visualization effect also, even in the macro range and even in the nano scaled of range can be examined by the scaling of the object, depending upon the lens capability. Depending upon the lens capability. The stereo vision systems that will provide the complete location information is in the triangular system. So triangular system in the sense, the opaque nature upon visualization, the opaque nature will be diverging on its widening of range. So in the picture, we'll be clearly seeing that variation. So for example, this is the common man who is visualizing, and his intensity of visibility is ranging with respect to a particular opaque. So up to this opaque. So the elements which are existing within these two opaque ranges can be clearly visible to him, and the front view of the object is very much clear to him, and he can examine it very much clearly. However, the computer vision is very much complex, which makes the stereo vision even very much difficult in measuring also. But virtually, even in the case of virtual aspects also, this can be guided by imparting at the end effector position by these vision systems and identifying the entire parameters clearly. Coming to the point of this uncertainty in the robotic systems. Robot systems in intelligent environments. So here, always we're replacing the intelligent. There's a good term deals with respect to the work commencement very rationally. This is the fraction of seconds by taking the input parameters, commencing the entire properties and generating the results. That's also within the allowable standards, or that will exactly confide with respect to the standard results. And these intelligent robots have the high capability to deal with sensor noise and even some of the uncertainty. Get deviated in generating its results when it feels uncomfortable. So, how those uncertainties will be taking place and what positions it will be taking place. First one is sensor uncertainty. So the sensor readings are imprecise and unreliable because this will not be varying. This will be varying apart or sublinear with respect to the standard results exist. అంటే అనుకున్న స్టాండర్డ్ వచ్చిన ఎక్స్పెరిమెంటల్ ప్రాసెస్ చేసినప్పుడు వచ్చిన రిజల్ట్స్ మనకి రావాల్సిన స్టాండర్డ్ రిజల్ట్స్ ఇస్తారు. ఫర్ ఎగ్జాంపుల్ 0.5 ఆన్సర్ మనకి రావాలి, 0.2 నుంచి 0.7 మధ్యలో ఏదో ఒక ఆన్సర్ వచ్చిన the answer is correct, valid point. And that's what we will be observing in our data book also. BMM subject కానీ DOM subject కానీ మీరు వెరిఫై చేస్తారు. సో 0.2 నుంచి 0.7 మధ్యలో ఒక ఆన్సర్ రావాలంటే మనకు వచ్చిన ఆన్సర్ 0.5 వచ్చింది. ఇట్స్ వేరియబుల్. It's a variable in between 0.2 to 0.1, and hence the obtained value is correct. And if it exceeds the 0.7, that is obtaining the value 0.9 or 0.10 or 1.0, 1.11, it is upstreaming the variations, and downstreaming in the sense 0.4 another up to value 0.2, 0.3 in such a way. So it relates that sensor uncertainty because it is lacking with respect to its connectivity or operating source or its capability. So that is one of the malfunction existing. We can say that malfunction that is being taken place in the case of sensor. Next one, non-observability. So decreasing its opaque variations or identification aspect, and action uncertainty. So actions are failed. So we can consider a best example related to it, that pick and place of robot. Pick and place of robot. So robot end effectors to on mobile phone on the upon it. The table train check this is it. And upon orienting with respect to 90 degrees of alignment or 120 degrees and between acute angle or obtuse angle, it should be oriented and it should be unloaded at the particular table. So upon holding, it doesn't hold very much tightly. It leads to failure of the entire product. That is one signature. Second one, it is upon placing from one place to another place, if there is any deviation within the inclination, that is one of the drawback. Next, the loading conditions, holding very much tightly or loosely. So if it has been holded loosely, it will be having a slight defect in sliding of the object, that is skipping of the object. And actions can fail. And when the end effectors, when you have dealt with respect to the end effector topic, we are having two different types of end effectors. First one is a gripper. Pick and place to circuit gripper plays a major role. Next one, tools. So tightening and loosening of the nuts and bolts. So actions cannot be fulfilled if the uncertainties has been happened. So tightening, full tight will be of 6 revolutions, but only the 5 revolutions has been taken place. So the tightness will not be existing. Upon loading conditions, it leads to loosen automatically when the certain loads has been applied in the working process, right? And that actions will be creating some of the disturbances for the happening of the work or commencement of the work. And these are the different kinds of disadvantages that will be arising because of the uncertainty of the robots. And how these will be getting calculated, and what is the perfect reason for the uncertainty happening, and how we will be eradicating it, and why we will be identifying it initially, and how we can be eradicating it. So here we are having the probabilistic robot localization. So the probability, the name itself, it is clearly specifying the probability. So how many number of ways of instructions are existing? So that we need to be chatted out first. We should have a polynomial confiding regarding the work strategy and whether that work will be commencing very much smoothly or not, and for what purpose will be utilized, and the time particulars, how much time will be sufficient for performing a particular task which has been programmed. That need to be identified very much clearly, and where it will be used for the localization, only for the localization. That is the urban area. A particular radiographic range from the controller point out. Next one is the mapping and modeling, model building. Enforcements and localization have the trial of the simulation concept. Related to that, the mapping has to be fixed and model building has to be considered. And if you have got okay, then it will be happy for installation. దీనికి మనం ఒక బెస్ట్ ఎగ్జాంపుల్ చూడొచ్చు. కొన్ని యాప్స్ కూడా మన దగ్గర ఉన్నాయి. ఊబర్ కానీ ఊబర్ అలాగే Ola outing, automobile booking points. So those will be existing only to a particular extent of distance, particular radiation of distance. And in and around or surrounding of 50 kilometers of range or 40 kilometers of range, that will be fixed and that will be getting random. And further, the models will be getting the mobile numbers or vehicle numbers or tracker will be fixed for the vehicle and tracker ID will be placed in the map. And by that, clearly we are examining in our mobile also due to the only radiation factor up to a particular fixed radiation. And then clearly we are visualizing upon booking Ola Gaudi, Ola Capital measures and where is your point, it's clearly specifying. And what is the nearest vehicle with respect to you in the centralized server they will be observing and clearly giving you the assistance. And so once a vehicle has been booked on behalf of you, and that concerned vehicle is coming towards you within 5 minutes. And time also will be getting clearly specified in the application and the route map from which sides and from which directions from left to right the vehicle is being coming. Clear cutly we can have a good in our application also. And that's the probabilistic about localization. And this is the best example for it. And indeed to comments this kind of characterizations, how the controlling measures can be taken for the successful operation of this strategy. So sensors is only for giving the feedback or giving the signal, particular signal that either may be of the input codes can be carried towards the different places by the signal measures or signal jumpers. And later on the entire activity will be getting progressed based upon the given program. And what are the results that are being obtained will be captured and those will be commencing in the form of actions by the actuators. Coming to the point of its architecture, here we have a clear-cut flow chart. First one sensors, sensors 2. Its perception. Perception here clearly specifies that up to what range the sensors are existing. Whether it can be complete with respect to work or not. And if at all it is okay, how many possible ways are existing. And apart with that, if the possible ways, among the possible ways have been identified only the major way, that way will be modeled initially. And depending upon the modeling, respective planning has to be charted out. Based upon the planning, the task execution will be taking place, and the task execution will be coming into the live actions by the help of this motor control towards either it can be towards the theta rotation towards by 30 degrees or 60 degrees or 90 degrees, etc. And that will be done in the live basis by the actuators or links which is connected with respect to a actuators at that particular joint. Coming to the point of advantages, the reasons about the contingencies or certain problems. It computes the solutions to the given task, whether it can be the task, and the goal-directed strategies. So goal, and it is possible in the present days kind of technology. There is PLC-based programmable logical controls. So here logic specifies that confiding of the work. So end logic, if input 1 and input 2 both are being switched on, then only the output will be executed. So there is a logic. So if any of the input 1 or input 2 get deviated, simultaneously the output will not be getting executed. Both will be so both the input values need to be specified clearly, and output need to be tracked out by the goal directed strategies. And what are the strategies mean? The way of giving the program to execute. And what are the disadvantages or limitations or problems existing to deliberate control of these architectures? The solutions tends to the fragile in the presence of uncertainty. That means fragile in the presence of uncertainty. So the uncertainty we have been clearly visualized in the previous slides. So due to the improper fittings, due to the improper programming, improper functioning will be leading. And at that particular time, particular solutions will not be tending to come into the picture. Accurate results will not be generating at the output range. That is one of the different and requires frequent replanning. So based upon the current situations, replanning is required. As we have been discussed this whole of thing and overbooking, like somebody will be initially booking and within after completing 2 or 3 minutes, they will be used to cancel the trip and again rebooking. So for that, again replanning need to be taking place. So source position and what is the destination position that need to be identified very much clearly and reacts relatively slowly to the changes and unexpected occurrences. So obviously we will be having the slow basis of reactance. And the architecture of this behavior-based robotic control architectures. Say first one, sensors will give the initial. What is the reason existing about the behavior of objects? And certain plan would changes the world, changes to the present world, particularly certain spaces, identifying some of the objects and monitoring the changes, building some of the roadmaps for exploring the task, exploring it, and wandering it, and avoiding the objects. So, based upon these parameters, the actuators need to carry on its work. So that is one of the best assertion. What's the reactive behavior based on controls on which will generate the simple behaviors upon subjecting a particular task and even its confidation of the task, because you have been specified 10 different tasks. So initially what task has to be prioritized and later what task has to be prioritized. So initially this is a best example for behind one of the best example. Old copy of introduction, introduction. And next the JPG printout. 3 different modes I have given printout. But printer will ask me that initial first serve first out was the primitive rule. The first serve in the sense word copy, the prediction of that need to be executed first. But I'll be opening the controller and selecting this image processing file to come as a first priority. So first print out will be a picture of JPG. But initially I have given input as third input, and what first output is coming is that third input is coming as a first output. So that's a prioritization. So indeed to give the particular task, subtask, it achieves the particular task on the overall task to the actual. And some of the complex behaviors from the simple elements that will be generated towards the vehicles. And in the automobiles, it plays a major role to control the simple mechanisms. And even some of the mobile robots also by fixing only the 2 leg sensors. See here, two-word situations, the two light sensors, positive, positive. These are related from the Brightenberg vehicles. So the name Brightenberg is the same as this. Given the clear cut formulation regarding the operation of these complex behaviors and how these can be controlled with a simple mechanism. The differential drives here. See, here we verify there's an forward position, there's an aggressive position, which are having both the controversial striking incremental is allowed and explore position is having the drastical output. Externally, the behavior upon given the input. And these are the different levels, and these levels varies with respect to different programming significations, and these can be controlled by the controller. Just now, as we have been discussed, that what is the printout need to be given as per the prioritized basis. Based upon the architecture, also we are having some of the advantages and some of the disadvantages. Basically, with respect to controlled architectures, it reacts fast in changes and not delay on the accurate models. Planning in the case of this standard architecture. Coming to the disadvantages of repetitions, requires redesign of control system, difficult to construct the strategies. And these are some of the hybrid control architectures. Hybrid control architectures combine with the reactive control with respect to the abstract task plan. So what the input that we are being given, that abstract task plan also will be existing, and what's the behavior? Behavior in the sense that depending upon the type of environmental factors that may be getting deviated in its actuations, and as per the motors, whether the given task of rotation is being executed by this motor or not, that will be sensed as an output, and the sensor will do the feedback back to the behavior of the set, whether the given input has been satisfied or not will be verified by the sensors. And if not, the pre-processor sensor data will be activated in the case of this abstract task plan. And for the rectification, again, the compensatory activities will be taken place. So here, if you've been verified clearly, abstract task planning is one subclassification regarding the hybrid control architecture, and next the reactive behavior plan. So deliberately, we will be taking the decisions and plans the goals-oriented policies as per the given abstract. So abstract in the sense clear-cut input signals, clear-cut processing signals, clear-cut output. So output also should be achieved in this particular range only, in vice versa. Like that, we'll be having a confined over it. So that's an abstract task plan. So in a shortcut, entirely inputs will be given to the system. Coming to this reactive behavior layer, it provides the reactive actions and handles the sensors and actuators for commencement of the work based on the sectional axis. This is the task plan. We're having the movement from one coding to another coding. We're having digitally will be having the coding factor, and each and every coding will be adjusted with only 0 and 1 number, 0 or 1. So that specifies with respect to the different numbers and behavior strategy. And behavior upon holding the object, so it has to be sensed. So touch sensor, the feelings need to be captured. So how whether it is existing in a smooth surface or not, smooth finishing is existing with respect to that particular material holding by the robot or not, and how much diameter it is existing, whether it is cylindrical or else any flattened surfaces, pentagonal or hexagonal structure, and how much threading there are being existing for this holding object, entire by sensing, by holding and sensing the feedback signals will be given. This is an end effector given to the motor by these feedback elements to the controller. Sensors we will be examining and the results will be fed back to the controller. That's the behavior strategy. And that's why we are calling as an intelligent plan. So reinforcement learning in a hybrid. So this was architecture will lead to increase the standard policies. Standard policies. That is nothing but the reinforcement. In our mechanical language, reinforcement is nothing but increasing the strength for existing object. So how will be taking particular steps, prioritized steps for increasing the strength for that particular material. So in such a way, we are having how to implement this technology, how to increase the frequency or how to increase the precision of the work that is already existing. The policy acquisition layer, it learns the task without the supervision, so without having the supervision, by observing the problem, simultaneously the concerned result need to be generated, it has to generate on its own. And next, abstract plan layer, learning the system model and basic state space compression, reactive behavior layer. So initial competence in reactivity will be. So here in the block diagram, a tree-shaped diagram, and we will be calling this a hierarchical diagram also. So reinforcement layer, abstract task plan is common with respect to the previous planning and behavior planning. And policy, concern policy will be getting updated, and state of information at each and every state will be getting achieved. So if there is any lagging occurring, when compared with respect to the standard results, automatically this reinforcement layer will give an updation regarding the policy to the abstract task planner to execute the behavior actions for the behaviors. And this behavior set will guide the motors for completing the holding task. So which is having a slight deviations that also will be overcome in such a format. That's a reinforcement. So reinforcement means in our mechanical language, reinforcement of the materials of the cast iron, which is one chip down, nothing but increasing of the strength. Reinforcement. So in such a way, operational parameters for the robot also for its architecture, nothing but feeding, giving the input and observing the output. So whether it is being obtaining in a precise manner or not, will be observing very much clearly. That's the reinforcement of the hybrid architecture. So need to happen the correct behavioral actions at each and every stage of the robot. This reinforcement creates that particular strategy. So there is of reinforcement learning in a hybrid structure architecture. Right. Thank you. By this we will be concluding our second unit also. And from the next class, we will be going on with respect to our third unit.